So looking at number 16 on worksheet 4, calculator problem. Particle moves along the x-axis with velocity given by this equation. I mean, I know it says it, but like you've got to make sure your brain is thinking, all right, that's velocity, so its derivative would be acceleration. So just keep that in mind when you're plugging things in. For 0 to 2 pi, units for velocity are meters per second, and units for time are seconds. Okay, so I already plugged this in, and I played with the window to get a picture that looks okay. This is one, if you do the standard, you don't really see much. So you got to play with the window until you see something good. X window is given, 0 to 2 pi. Y min and max, I was just playing around with until it looked like I saw everything I need to see. All right, part A. What's the acceleration of the particle? Well, acceleration is dv dt at time equals 2. So I need to see that. Don't just give me the answer. I mean, I assume that's what you're doing, but you have to tell me that's what you're doing. And I think a lot of you were doing it on the graph. dy dx at 2. So there's my slope at time 2, negative 0.179. Indicate units. Hopefully you've had physics enough to remember that acceleration is meters per second squared. But even if you forgot that, velocity is meters per second and time is seconds. So even if you have to figure it out from sort of this formula, that's fine too. Meters per second squared. Some of you, I think, are doing this on the main screen, like where you do it this way, which is also fine. You get the same answer. I think I prefer to see it on the graph because I can tell by looking at the graph that the slope is negative, so I feel a little bit better about my answer. Not that I'm doubting the calculator, it's just I get a better feel for it. Is the particle speeding up or slowing down? So that means velocity and acceleration, are they fighting each other so it's slowing down, or are they pointing the same direction so we're speeding up? Well, A of 2 we just found, negative 1.179. So I need V of 2, which again I can find on the graph. Value at 2 is 0.123. So what's my answer? Speeding up or slowing down? Slowing down, and why? What's the justify? The signs are different. A and V have different signs. Again, anytime it says justify, you've got to give a verbal reason. A picture is not enough. It might be enough to convince you, and that's good, but I need a verbal, brief explanation. Again, from my Facebook friends, the main moderator, when he talks about justifying, his motto is, if I remember right, be brief, be accurate, be gone. So say what you need to say quickly, and then be done. Like, kids get into trouble when they start trying to give some paragraph explanation of velocity and acceleration. I don't need that. Give me the calculus reason, and then you're done. I don't want an explanation of how this works. Just tell me how you knew. Part C, average acceleration. So acceleration is change in velocity over change in time, but we have to be careful here. The instant acceleration would be dv dt. That's not what this is. That was what part A was. The average acceleration is change in velocity over change in time. So instant is a calculus thing. Average is an algebra thing. This is like calculus slope versus algebra slope. So it's not an MVT problem, but it uses that same idea. So I need v of 2 pi minus v of 0 over 2 pi minus 0. And I guess I should plug them in, but I can tell by looking that v of 2 pi is 0 and v of 0 is 0. And I guess I could just leave that as my answer. Indicate units of measure. Well, we've already done acceleration units of measure, so meters per second squared. Again, if you get stuck on units, you can still use meters per second, and that would be fine, because that is accurate. So the average acceleration is 0. That's because your starting and final velocities are the same. So your average overall acceleration was 0. You didn't change, even though individually there's some changes going on in there. Part D, between 0 and 2 pi, when is the particle farthest to the right? And I saw a few of you even had a picture drawn, like that's what farthest to the right would look like. So before it happens, v is positive. After the turnaround, v is negative. So I'm looking for where, here's my justify, where v changes positive to negative. V changes positive to negative, because that's where, it was going right, and then it changed to going left, so that would have been the farthest right spot. So the picture is of velocity, so it changes positive to negative, not up there, that'd be where acceleration changes from positive to negative at that peak. But velocity changes positive to negative wherever that spot is. Second calc 0. Left bound, right bound. By the way, you'll know you've gone far enough right if you look at your y value and it goes negative. That means you've crossed the axis and you're into the negatives now. So that happens at t equals 3 decimals, 3.142. Now, that also is pi, but you don't have to know that because it's a calculator question. So to 3 decimals, time equals 3.142. And the reason is that's where velocity changes positive to negative. Part E, where does the particle change directions? Justify your answer. Well, change direction would be where v changes signs. So there's my justify. And the only place it changes signs is at the place we just found. So that's kind of weird that D and E is the same answer, slightly different reasons, slightly different question, but the same answer.